Hello, second period, seventh period, eighth period algebra students. This is part 2 of your review video. We're going to focus mainly on operations with polynomials. I was very surprised at the difficulty many of you were having on Monday, so we're going to hit this pretty good. All right, first of all, you need to remember addition and subtraction like terms. Like terms. And we are only counting the like terms. We're only counting. So exponents will not change. They will not change in addition and subtraction. Multiplication is different. It's about grouping. Exponents might change. But let's take a look at this. Look at problem number 1 here. In fact, okay, problem number 1. Where's my highlighters here? Okay. What kind of terms do I have here? I have x to the 4th terms. How many x to the 4th terms do I have right here? I have 5x to the 4th. The number in front tells me how many there are of that. Okay, then I have positive 6 more x to the 4th. So I'm counting x to the 4ths. How many x to the 4th do I have? How many do I have? Well, I have 5 here and 6 here. So I have 11 x to the 4ths. You see? The exponent does not change because I'm not counting x to the 8ths. I'm counting x to the 4ths. If I'm counting cookies, you know, I got 2 cookies here and I got 3 more cookies here. Do I have 5 cookies squared? No. 2 cookies plus 3 cookies equals 5 cookies. Not 5 cookies squared. So make up a simple example and test it. All right. Number 2, 3x plus 2x. Heck, you better be able to do that one after what you just listened to. Come on, Aiden, you shout it out. Shout it out so everybody can hear. Make your parents think you're strange. That's all right, they already do. And don't worry about it. You think they're strange too, right? No, I'm sure you love your parents. No big deal. Just, they always look at teenagers and scratch their heads, but we used to be strange like that too. In fact, most of us still are. Don't tell anybody. All right, 2x plus 3x is 5x. Okay, number 3, I've got 5x to the 4th y's. Hey, what kind of terms are these? These are x to the 4th y terms. And there's 5 of them. Yeah. And then I'm taking away 4x to the 4th y's. Taking away 4 of them. What am I left with? Well, you can do it one of 2 ways. You can say you're left with 1x to the 4th y's. Or you can just say x to the 4th y. It means the same thing. Either answer is okay. By the way, before we go on to problem number 4, I need to ask you. My honors kids were driving me nuts the other day. They had 10x minus x, and they were telling me the answer was 10. Oh my gosh, no way. If I have 10 x's, 10 xylophones, and I lose 1 xylophone, what do I have left? I have 9 xylophones. Okay, you guys are too far along to be making that mistake. Please don't make that. I was very distraught with my honors kids the other day when they told me that. All right, let's get down to problem number 4. Now, x times x, I think most of you have memorized as x squared because you've heard it like 8 billion times. Okay, remember, the exponents are 1 and 1. And so 1 plus 1 is 2. Right? In multiplication, we're saying the simplest way, we're trying to find the simplest way to say x times x. Well, x squared. Now, it doesn't seem a big deal, but what if I got to do x times x times x times x times x times x? Oh, you guys are cruel. You're making me do this with a sore throat. All right, well, how many x's are being multiplied? 1, 2, 3, 4, 5, 6, 7. I don't want to say x times x times x times x times x times x times x. So I'm going to say x to the 7th power. Okay, this tells me how many x's are being multiplied. Pay attention to your operations. Okay, the rules for addition and subtraction are not the same as the rules for multiplication or division. All right, so let's test this one out. Number 5. Let's do 6 times 2, and we're going to get 12. X to the 4th times x. Well, that's an x to the 1st, isn't it? So that means my product is x to the 5th. Right? I multiply the coefficients, then I multiply the variables. This one looks hard, but it's easy. I'm going to multiply 5 times 2, and I'm going to get 10. X cubed times x to the 4th. How many x's are being multiplied? 7. 7, because there's 3 here, and there's 4 here. Now I'm going to do the y's. So I'm going to do y to the second times y to the eighth. Well, y to the second is y times y. And y to the eighth is this. 3, 4, 5, 6, 7, 8. How many y's are being multiplied? 10 is the correct answer. There you go. All right, now the problems you actually do on the test are going to look more like this, where you might have to add or subtract. In this case, you have to subtract two quantities, but there's a number out here, so I got to distribute, right, to all three terms, right? And so I'm going to get 6x to the fifth minus a 2x squared minus a 8. And then I'm going to have a negative 4x to the fifth, a negative 4x to the fifth. I'm going to have a negative 2x squared. And then I'm going to have a positive 3x, right? Because a negative 1 times negative 3 is a positive 3x. I'm going to simplify and get a 2x to the fifth minus 4x squared. I'm going to write this 3x first because I like my terms to be in descending order, and then a negative 8. And there you go. The problems might get a little more complex than that. You know, you might see something that looks like this, say 6x squared minus 4x. I'm going to put a 2 in front of there and a negative 3 in front of there, and I'm going to negative 3x. And then I'm going to put an x plus a 5. All right, I'm going to distribute in this first quantity, get 12x squared. That's supposed to be an x squared. Sorry, that looks terrible. Let me rewrite that. 12x squared. Then going to distribute there and get negative 8x. Distributing the negative 3x to x, I'm going to get a negative 3x squared. Right? And then distributing there, I'm going to get negative 3x times 5, which is a negative 15x. Combining like terms, 12 minus 3 is 9. Oh, I wrote x to 9. That should be an x squared, excuse me. X squared. Negative 8, negative 15 is negative 23x. And there you go. All right, let's back this up. There we go. Back to the page I want. Uh-oh, I'm having trouble here. Danger, Will Robinson. There we go. All right, come down here to this multiplication problem. Now, some of you are refusing to do it this way. If you can do it using the arrows, I don't have a problem with that. You got to be careful. You can do it with the arrows. That's great. If you can't do it with the arrows, please try it this way. 6x times the quantity of 3x plus 4 minus 1 times the quantity of 3x plus 4. And then I'm going to distribute. 6x times 3x, 18x squared. 6x times 4, 24x. All I did was multiply here and multiply there again. Distributing a negative 1 will give me a negative 3x minus a 4. And now I'm going to combine like terms. I'm going to go looking for like terms. Let's see, I've got I have a small mistake, don't I? I have a 24x, but I only wrote down 24. There we go, that looks better. So looking for like terms, I'm going to take this 24x and a negative 3x. The other numbers are not like terms at all. All right, so I'm going to combine the like terms. I'm going to have an 18x squared. 24x minus 3x is 21x minus 4. And there you go. All right, this one here throws a lot of students, but stop and think what the exponent means. X squared means there are two x's being multiplied, right? 5 squared means there are two 5s being multiplied. So the quantity of 3x plus 2 squared means there are two quantities of 3x plus 2 being multiplied. All right, and all you have to do is multiply it out. I want you to go ahead and do that. Pause the video. When you're ready, unpause the video and see my solution. If you're still watching at this point, I assume you've already done this multiplication. I'm going to get 9x squared plus 12x plus 4. Okay, I did all the steps in one. there is your answer. If you're not sure how to do that, ask. Okay, problem 10. Some of you don't like it this way. Some of you would rather rewrite it like this. I'm thinking of Mackenzie Mayo. And that's totally cool, Mackenzie. You go ahead and do that. You can rewrite it using the commutative property, right? Okay, since Mackenzie likes it so much this way, I'm going to do it this way. I'm going to break it up. I'm going to take x, and I'm going to multiply by 3x squared minus 2x plus 5. And then I'm going to take a negative 5 times the quantity of 3x squared minus 2x plus 5. And now I'm going to distribute x times this guy, and this guy. So I'll get 3x cubed minus 2x squared plus 5x. Then I'm going to do negative 5 times positive 3x squared. Then negative 5 times 2x. Then negative 5 times positive 5. So negative 5 times 3x squared is going to be a negative 15x squared. Negative 5 times negative 2x is going to be a positive 10x. Negative 5 times positive 5, negative 25. And now I am ready to combine like terms. Now, on the test, you're also going to have to be able to name things by degree. You know, is it linear? Is it quadratic? Is it cubic? Is it quartic? Right? And remember, these are what? First degree. This is second degree. This is third degree. This is fourth degree. And then after that, we can just go ahead and say degree 5, degree 6, or whatever. We always look at the highest exponent. So for example, number 10 is going to be cubic. Number 10 is cubic. Okay? Number 8 is quadratic. Right? So is number 9, because the highest power is 2. Okay? But then we also have to name it by the number of terms. Is it a monomial? Which means there's one term. Is it a binomial? And that would be 2 terms. Is it a trinomial? Well, that would be 3 terms. Or is it a polynomial having 4 or more terms? Okay, well, let's look at number 10 here. Looks like there's 1, 2, 3, 4 terms. So this is a cubic polynomial. Cubic polynomial. All right. Number 8 is a quadratic trinomial. Right? A quadratic trinomial. So is number 9. Okay, let's jump up here. It looks like number 7 is a degree 5 polynomial. Right? It's a degree 5 polynomial. Number 5 here is a degree 5 monomial because there's only one term. Okay, namely 12x to the 5th. All right, that's my one term. All right. Number 11 would be number 1 would be a quartic monomial. Number 2 would be a linear monomial. Right? Okay, that's it for your video. Hopefully you've been working on your review sheet. This test is very important to many of you. Mr. Lawrence signing off. Have a good night, everybody.